Hey guys, welcome back to the video. And in today's video looking into the topic, which is the problems, the numericals of the topic, the chapter scalars and vector. And uh, that is kind of an important video, and we'll be doing different sort of problems and clearing the concepts. uh, I'll be taking a break to write the question, so meet you back with writing the question, the number one question. Okay, so I'm back with the question. So let's look into the question. What does the question says? So let's see. uh, Here it says the following forces act on a particle P. There's a particle P, right? The particle P, and forces act on it. Forces act on particle P, right? There's a point, the particle P, the forces are acting on that point, and we are given the forces. Force 1 is this, force 2 is this, force 3 is this, and force 4 is this. This means that four different forces are acting on a point, that is P, and we need to find the resultant vector, and secondly we need to find the magnitude of the resultant vector. We need to find magnitude and the resultant. First of all, we will looking into the the resultant vector. With that, I'll be looking for the magnitude. So let's go for the solution. Let me make you more clear about this question. What the question says, like it says that this is a point P. This is point P. So this is a point P, and from here we have got F1, which acts over here on this point. This is F2. Like we have got four different forces. The values of these forces are given. Now what we need to do for this question, what I will say is that we'll be simply adding up the forces, because there is no any concept of angle given. We have just four different forces, they are acting, and we are given no angles, so we just need to sum all them up and take out the simple answer. If angle would be given here, then the case would be different, and we're looking into that case in our upcoming videos. Then the formulas get changed, but over here that would be simple. Like we need to add the result. We need to find the result vector. Just add these forces. There's no any concept of angles give, like you need to say that force 1 is at 260 degree to force 2. This is not the thing. You just need to take out the solution. So here this is solution, and first of all we're looking for A. Now what the A says, we need to find the resultant vector, and for suppose, okay, the P is a particle, and the resultant vector we name it as this P over arrow. And this P over arrow is equal to force 1 plus force 2 plus force 3 plus force 4. You find simply adding them up. If no, this is kind of a simple, very simple problem. We're looking into complex problems in upcoming videos, maybe in this video as well. Force 3 and force 4. Now this is kind of your work to find out the put all the values. Just need to put force 1 value, force 2 value, force 3 and force 4. You need to all these values, and I need your answers. I'm telling you the answer would be this. Answer would be equal to 2I minus j. You need to find, this is your task, this is your homework, 2I minus j, and just you need to pick the values of force and they add them. That is kind of a simple thing, and I do say that you need to try that out, and you will be getting this answer, 2I minus j. This is the resultant vector, right? And now what is the second part says? Second part says magnitude of the resultant vector. Now what B says, we need to find magnitude of this is a magnitude, this is a resultant vector which you have found it, and what is magnitude, we have got modes over it. And what is the formula? uh, like over here, if we see that what we do, yes, we do sum up, put analytical, like we do sum of all the forces, uh, you know it will be happening like this. uh, Resultant would come over here, and then like radical will come, then 2i square 2i square minus j square, and what would we find is that is minus 1 for j. The answer would be p, uh, the magnitude would be equal to radical 5. Radical 5. This is how it works. You know why we did this for this all method. uh, like in the case of unit vector, we have got this formula, right? We are known that unit vector is equal to uh, the vector for the unit vector is equal to, you can say here, p is the vector, p upon magnitude of p. Now over here, if you see magnitude of, sorry, this is p, this is p. Here we're doing this again. Okay, so this is magnitude of p, and a are for the unit vector, and here we can say that p magnitude according to this formula is equal to p over vector p over unit vector. Right. Now what will happen is that uh, we will need to find the unit vector to find this out, and that would be kind of a complex thing. Like, that is very very complex. So we just do this form like this. For if you're doing this form, you can obviously do this, but here comes the same thing. Like, you need to find out the unit vector, and the unit formula is equal to this, and here you need to find the magnitude. Now for magnitude, we have got a direct formula like this. Like, we have got, if we are finding the magnitude of this f factor, that would be equal to whatever the number of forces we are having, or the direction where force is acting upon, like I square plus j square, a plus a square plus b square, and even though it goes on, the series continues over here. This is how it works. I've given you the concept, like why we are not using the unit vector formula and all that. I do have learned something. Meet you guys in the next video. Till that, goodbye.